Welcome you all for the good afternoon everyone, and we welcome you to the today's webinar on geospatial technology for hydrometeorological disaster. So without wasting any time, I invite Dr. Praveen Kumar Thakur, the chair of ISPRS working group 3x7, to introduce today's speaker. Dr. Praveen,
Yeah.
please.
Thank
Still
you, Dr.
2 minutes are
Vaibhav.
there, Dr. Praveen. Still 2 minutes
sir.
are there. I think people must be coming.
Yes, sir. Should we wait, sir? Hello. Hello, sir. Should we start? Dr. Vaibhav?
Sir is muted actually.
Yes, please. You can start. Okay. There you go.
Yes. So, good afternoon, everyone. Sir, should I start, sir?
Yeah, means you can start. 1 minute is there. You can start. Otherwise, we can wait for one. Okay, fine. It's up to you. I am ready.
Yes, sir. So, welcome all the participants of International Society of Photogrammetry Remote Sensing, Indian Society of Remote Sensing, and all the colleagues who have interest in our webinar series of Hydrosphere and Triosphere. So, today we have the third speaker for this webinar, Dr. SP Aggarwal, who is currently Director of Northeast Space Application Center, Department of Space, India, in Shillong, in northeast part of India. He has he has taken very important initiatives towards the effective utilization of space science and technology in various development activities of Northeast region, such as natural disaster management, infrastructure planning, disaster risk management, weather forecasting, satellite communication, ICT for geo-governance application, etc. Before this, he has served as a group head of Water Sources Department at Indian Institute of Remote Sensing, Dehradun. And Dr. Aggarwal is a highly accomplished scientist in the field of remote sensing and GIS, especially the applications of water sources management, disaster management, climate change impact assessment on hydrology. And at the same time, he has immensely contributed to the capacity building and outreach activities of ISRO, especially the International United Nations program, popularly known as CSTAP. And he has also extensively served the professional societies, including the Indian Society of Remote Sensing in various capacities as treasurer, secretary, and now as president of the society from 2024 to 26 term. And he has also contributed to the International Society of Photogrammetry and Remote Sensing as secretary of the TC5 on the capacity building and education. And also, he's currently the chair of working group 5x4 on education awareness in the disaster management, risk management. And he has been awarded for his contribution to the Indian Society of Remote Sensing as the President Appreciation Award, National Geospatial Award, and he has also been conferred the Institute of Engineers Eminent Engineer Award in the year 2014-15. So, without taking further time, I welcome Dr. SP Aggarwal ji to give his lecture on this important topic on the hydrometeorological hazards. Sir.
Okay, thank you, Dr. Praveen. I hope you can hear me.
Yes, sir.
And my slides are also visible now.
Yes, sir.
Okay, so very good morning to the people who are sitting in Europe and USA, and good afternoon to people who are sitting in Asia. I'm going to talk about geospatial technology for hydrometeorological disaster. So, as introduced, I'm currently working as a director of Northeastern Space Application Center. Once we are talking about the hydrometeorological disaster, the list is big. It starts from the flood. Of course, this is major disaster, but then thunderstorm, lightning, avalanche, hailstorm, cyclone, storm surge, even drought is also part of hydrometeorological disaster. Let me give you the global scenario of different disaster and how it is changing with respect to the year-wise or climate change. So look at the global scenario, and if you see the right figure, it is very clearly visible here. The dark, brown color, it is seen like India, China, Indonesia. You can see Philippines. You can see even USA. They are the biggest sufferer of these natural disasters. But out of that, if you look, Asia suffered the highest number of disaster events. In total, between 2000 to 2019, there were 3,000 plus disaster event in Asia, of course, followed by 1,700 plus events in America, and in Africa it was 1,000 plus events. If you look at the country wise, so China is leading in this disaster, followed by USA, then India, then Philippines, then Indonesia, etc. and etc. Now, I would like to highlight something that how things are changing. If you look at the 20 years before this century, like 1980 to 1999, the reported disaster were 4,000. Now, in this 20 years, 2000 to 2019, it has increased from 4,000 to 7,000 plus. So you can see that how disaster are increasing, and because of that only, like total deaths have increased, many things have been increased. This is purely based from the UN DRR report. If you look at the disaster, which disaster is really more affecting more, so you will find that flood is leading. You look at this. In fact, in 80 to 99, that flood events you see in 1389, and now it has increased to 3,254. And after that, second biggest is the storms, which earlier it was 1,457, now it is 2,043. So these are the two major disasters. Other disasters are also there, but number of events are less. Now, I would like to highlight the percentage of occurrence of disaster by disaster type. And here I want to highlight the role of hydrometeorological disaster. And I compliment Dr. Praveen to he has chosen this topic, the geospatial technology for hydrometeorological disaster. If you look at this, that leading disaster is the flood, 44%, followed by storm, 28%. Of course, earthquake is number three, then of course, other disasters also. So today in my lecture, I am going to focus more on these two. First is the flood, followed by that, that how the cyclones and thunderstorm, lightning, etc., etc. Now look at the India, because I'm speaking from India. So I would like to highlight something on India also. If you look at the flood area, so out of entire country, flood area like northeast region, it is affected. East part of India like Odisha, West Bengal, they are affected. This Gangetic plains are also affected. Even part of Uttarakhand is also affected. So these are the flood area where generally flood comes. Some small flood comes elsewhere in Godavari river basin here, somewhere here. If you look at that earthquake and landslide, so earthquake, of course, many places it comes, whether it is Gujarat also, maybe in Jammu and Kashmir and Ladakh, then in Himachal Pradesh, Uttarakhand, northeast region. So earthquake is there. But then if you look at the cyclones, so generally east part of cyclone is highly affected area. However, best part like Gujarat is also affected, and part of Maharashtra is also affected by cyclones. If you look at the tsunami, so tsunami is basically, the east coast is so far is affected. Sometimes we have seen Gujarat west coast also. So, these are the picture which I want to give you that India is highly prone. If you look at the total, like 12% of land area is affected by flood, 8% of land area is affected by cyclone, 65% of the land area is affected by drought, and 25% of land area is affected by earthquake. So you can imagine that India is highly disaster prone country. Now, what the geospatial technology and how it is helping hydrometeorological disaster. So when we are talking about the geospatial technology, so we are talking about the remote sensing. Now, remote sensing we can have from satellites. Remote sensing nowadays we can have from UAVs. Earlier we used to have from aerial aeroplanes, but now we are having drones or UAVs. We can map the hydrometeorological disaster. we can monitor, we can look into the damage, and we can also do the hazard zonation using the remote sensing data. GPS provide me the location. It helps me to get the location where to go for relief and rescue. And it is also used for crowdsourcing for affected areas, which can be populated to your web portal. Field data is also very, very important. And for that also location is required and field instruments are required. It also can go into the models so that it will predict the hydrometeorological disaster. Now, GIS is very, very important because it handles all the data set which you are collecting from these systems. So like you can create a database, you can input the database, then you can do the spatial analysis, you can go for multi-character analysis, then you can go for decision support system, and really you can visualize the condition of the terrain. Once you get this information, then you have to pass on this information in any disaster event to the people, and in that internet plays a major role. So like communication, alert generations we are using. So this is the entire gamut of the geospatial technology. Now, all these technologies can be utilized for different phases of the disaster. Preparedness, like activities prior to a disaster to plan how to respond. Then response activities during a disaster to minimize the disaster risk, like search and rescue, emergency, relief, public warning system, getting the information where is the disaster, how many districts are affected, how many villages are affected, where that geospatial technology plays a major role. Recovery part, like activities following a disaster in order to return the community to the normal, like temporary housing, claims, medical care you can provide. And of course, mitigation, like activities that reduce or minimize the effect of disaster, like infrastructure, donation, vulnerability analysis, public education. So all these technologies can be utilized for these four phases of the hydrometeorological disaster. Now, if you look at the flood, now I'm coming to the flood scenario. So you see these are the state and how many districts are affected. This is the list you can see. So almost, entire all the states, almost 24 states are affected of the flood. This is for 1988 and in 1998 to 2024 years data is there, and this is the area affected. Now, let us come, what is the principle of flood inundation mapping? Because you have to map where is the flood, which district is affected, which village is affected. So we can use optical data if cloud is not there. Generally, whenever there is a heavy rain, you have a flood. So rain comes from the cloud. So always you will find cloudy condition. So then you have to go for micro data. But if cloud is not there, very nicely you can see the flood area. So generally water resource, if you look at the water, it absorbs 100% of the whatever energy is coming from the sun. So, but especially in NI region. So any water body appears black in FCC. Look at this. This is a reservoir. So this is a black. These are the ponds, lakes. This is black. Right? But then flooded area is not a deep water body. It is not a clear water body. It has a lot of sedimentation. So flooded area will look like a cyan color. You can see in the background image. It looks like a cyan color. That is a flooded area. But the situation arises in whenever there is a flood, you will find cloudy conditions. So optical data is not working. You can look the optical data down image. You can see everywhere white color, cloudy condition. But the same date, if you look at the right side, is a micro data very nicely down right side image. You can see flooded area. A river is seen, but down you will see south of it, you can see flooded area. So in optical, it is not visible. So what we are doing when we are mapping the area, if cloudy condition, we are using the micro data. If not cloudy condition, we are using the optical data. If you look into different phases, in mitigation phase, flood hazard zonation we can do using the geospatial technology, vulnerability and risk analysis we can do, public education, location of shelter we can identify using geospatial technology, multi-criteria analysis. Prior to disaster, we have to understand precipitation, extreme event, thunderstorm, high precipitation event, land use land cover we can get, topographic parameters we can get, drainage pattern we should know, okay, and hydrological simulation we can have. So we can prepare the people that if this much amount of rainfall is occurring, your area is going to affect. For that, simulation is the best part. We are using different, hydrological model. You can use the lumped model, but nowadays in the era of the high performance computing system and era of the satellite data availability every minute, we are using the distributed hydrological model, so that it gives the idea that if this much amount of rainfall will occur with this much of intensity, how much area will be inundated, which district will be affected, which village will be affected. And this will help the relief commissioner and district commissioners to prepare themselves that if such type of rainfall occurs, then how we can help. During a disaster, we can generate the flood inundation map. Already I have given an example. I will show you many case studies later. Flood monitoring we can do by getting data every day. Infrastructure damage we can assess. Flood evacuation route we can identify. Relief and rescue, communication. Following a disaster, we can understand the socioeconomic loss, crop damage also we can get from satellite data, building loss also we can get from the satellite data, and accordingly we can pay to the people so that happily they can rebuild their infrastructure and they will be happy. Of course, rehabilitation, reconstruction, and counseling also through internet we can provide. So these are the different phases where geospatial technology can be provided. Now let us go one by one. However, flood hazard zonation atlases can be prepared for frequent flood affected state. That can be done using the last 25 years data, 30 years data we can get. Flood affected area atlas also we can get, like once in 10 years this area is affected, twice in a 10 years this area is affected, every year this area is affected. This will really help the people, the government, to prepare themselves for next year flood whenever it is coming. Flood vulnerability mapping we can do. Then flood risk assessment we can do using the flood hazard and flood vulnerability analysis. Now let us come to how to integrate the satellite image with the GIS layer, so that, see, you understand this is the remote sensing data, but the data should be disseminated to the district collector, relief commissioner. They are sitting in the districts. So this is a classical example. This is the flood area of Assam. Since I'm from Northeast, so I'm giving more example of Assam. And you can see that this is the district map. So in a GIS environment, I get a satellite data. I am georeferencing the satellite data. Already I am having a district boundary. I'm superimposing it, and I get this district is affected. For example, if you look at this, Dharang district is affected, Sonitpur district is affected, Jorat district is affected, Marigan district is affected, Barpeta district. Immediately you get this information. But then if you want to analyze which village is affected, then you have to go further. So you have to do district-wise analysis. So for example, I will take example of Marigan district. Now I'll come to the next. What I did, I separate out the Marigan district flooded area. You can see blue is the flooded area, and I superimpose the village boundary over it. And immediately in your GIS environment, you will find out how many villages are affected. Here you can see total 465 villages are affected. Okay. Now let us move further. Now this is the classical example of 2024 flood of Assam. Now this is what we are doing. This image analysis we are doing with the help of course, a National Remote Sensing Center. Now you may be aware that through Bhunidhi, you will get our micro data also, you will get our optical data also. So we get like LIS4 data, we are also getting IRS-1A data. And with the help of that, we can analyze. So this is what we have done. From 31st May in Assam, from 31st May onwards, the flood started. So every district were mapped, and this is the date wise which district is affected. You can see the animation. I am sure you can see this animation. I hope animation is visible, Dr. Vaibhav. Can you unmute?
Yes, the image is visible and well.
Animation is also visible.
Which one? Sorry, the animation. Yes, sorry, the animation is visible.
Okay, fine. So you know that this type of maps are generated and it is given to the state government. Now, monitoring part. So we take a everyday image. Of course, this I am saying for a classical like day one. If you look at this area is flooded left side. Same area, day 7, it is still flooded. But if you look at the down, day 14, flood is gone. If you look at the right side area, day 1, flood is there. Day 7, flood is there. Day 14, flood is there. Black color is a flooded area. So you can see like that, you can understand what is the duration of the flood. So with the different imageries, different date imageries, you can go for that total duration of the flood. And based on that, really you can analyze how much relief we have to provide to the people. This is another classical example, the optical and microwave together. For example, optical data shows there is no flood. On 20th of August, you can see there is a breach, embankment breach, and flood come down up to here. But there optical data showing totally cloud, but here no cloud. So you can see up to flood is visible through microwave. But then next 23rd August, you can see here that optical data, cloudy condition were not there. So I can see flood had reached up to here. Now you can see from here it has gone down to here. And finally later it has, so you can see only micro data because cloudy condition. So combination you can monitor. This flood was more than 1 month flood in Kosi River. It's a long back. But just to maintain the continuity where to use the optical and microwave, I have shown this example. And of course, courtesy to National Remote Sensing Center. Now I'm giving few example of 2024 what you call floods because I'm talking in 2024. So this is a classical example. This is IRS-1A data, our Indian remote sensing satellite data, microwave data we have. Look at this. This is before flood. This is the area. This is a beautiful river is visible. You can see here. But then, and you can see very nice area. But then July 6, 2024, you can see all compare these two images, all black color you see, you will find flood everywhere. So this is for Jorhat district in Assam. Now this is Dibrugarh district, January 2024. You can see nice river is visible. This is a mighty Brahmaputra river, and you can see nice area. But then July 1, 2024, you can see many places you have a flood. Now let me move further. Flood inundation in Dhemaji, January, very fine. But then 2024, flood is there. So what we are doing, this image is provided immediately to the State Disaster Management Authority for their action. Now this is animation again. You can see two images, before flood and after flood. So sometimes we provide to the district management authority such type of animated image so that they will understand exactly where flood is. There is a possibility of permanent water bodies. To separate out from permanent water bodies to the flooded area, so this type of animation is required. So they will understand, okay, this is a permanent body, this is not changing, but some additional area of flood is there. So immediately they will act upon it. Now, but then many a times it happens that you need much more resolution data. That time drones are very, very important. And we are flying drones. We have a different kind of drones in Northeastern Space Application Center. And always I say that drones complement the satellite data. Because when satellite data is not available, your team goes there and it fly and you can get. For example, this is the classical embankment breach during that 2022 famous Silchar flood. And you can see the UAV drones we have flown and you can see a breach in the embankment. But the resolution is very high. The here resolution is 4 to 5 centimeter. So very nice embankment breach. So exact location you get with this, and you will be surprised to know that that time even data was not available, satellite data was not available. It was only our information, your drones information only, which helped the district administration to provide the relief to the individual houses which are there in the flooded area. Another very classical example I am showing you, the debris flow, and because of this debris flow, the rail, you can see the rail, it has gone other side, you can see now. It pushed, the debris flow pushed this, and now this railway coaches, you can see train coaches are here. It should be here, straight line, it is here. Again, it is mapped, every inch of the area is mapped from the drones. But exactly what is the damage? What is the length, breadth, everything? For that also drones helps. I will show you third picture. Look at this. This is a railway line you can see very nicely. And here you can see exact length, breadth, and how much area, that length of the railway track is affected. All these things you can map using the drones. So for damage assessment, you can use the high resolution data, but also you can use the drones as and when required. Okay, now let us come to the cyclone. So cyclone, I'm showing you an example. In 1999, October 99, there was a cyclone, super cyclone in Odisha, and more than 10,000 people died. Similar magnitude cyclones, now also they are coming in India. And last, you can say 20 years after this, 4 5 cyclones of this same magnitude came, but hardly 2 3 people died. The reason was basically the accuracy of cyclone tracking and prediction. And this can be achieved using various satellite data, various field data, various DWR, all these things we are doing. So how we are managing the tropical cyclone hazard using so we are using different satellites. For example, in this slide, it is visible. We are using our own Indian satellite inside 3D, 3DR, 3DS data. Real-time monitoring we can do every 15 minutes, every half an hour, or every 15 minutes if required. We can monitor the cyclone eye or cyclone. So from where it starts, actually, genesis of the cyclone. We can forecast the intensity, landfall location, and time. Then we can also get the cyclone structural information. Scatterometer, we have scatterometer. Scatterometer data provides the cyclogenesis prediction, geolocation estimation, cyclone size estimation, wind and wind speed is also very, very important. Because unless you know what is the winds and wind speed, then you cannot tell what is the level of the cyclone, whether it's a class 1, class 2, class 3, class 4. Of course, I'm calling cyclone, but somewhere it is called typhoon, somewhere it's called hurricane. Then, of course, this microwave humidity sounder data provides that the cyclone structure also. So these are the few images. And even genesis also. Cyclone may hit this area, but genesis starts from here. That can be seen. Even lead time is 72 hours. Even nowadays, it has been much better. But then after cyclone, you should understand how much area is inundated. So this is a Hudud cyclone in India. You can see before cyclone and after cyclone, right side microwave image. If you see, you find all area is inundated. But the damage, cyclone also create the damage. So look at this. This is the satellite data, and you can see here rooftop of near to railway. This is the railway station somewhere. This warehouse is there. You can see rooftop is intact, but post event you can see totally damaged. So such type of satellite data you can use, and you can understand the damage. If satellite data is not available, I will recommend you can go for drones. Now I'll come to a topic which is very, very important and which is saving hundreds of lives in our country. And that is the flood early warning. Now, how to achieve this? For that, first and foremost is we should predict rainfall. And for that, there are various models and lot of data, satellite data, field data is ingested into it. So we run the model and we predict the rainfall for next 48 hours, 36 hours, 24 hours. Like that, we predict that rainfall. This rainfall goes as an input to the hydrological models, which generally people can use any model, but we are using here in Northeast HMS model. And then hydrograph is generated. Now, in this hydrograph, we have already AI-based, threshold. So once that is crossed, immediately the flood alert is generated. Now, based on this peak, we will tell it is a low flood, it is a moderate flood, it is the high flood. So this is the Danish, this total, I think 43 subcatchments are, this entire area is divided into the 43 subcatchment, and each catchment we have established the hydrological model. Okay. So this is very important. It really saving the life and property also. Our success rate, if I tell, in few, of course, this is 21, but I have analyzed 20. In fact, I have analysis for last 10 years, and it's almost same. It comes around 85 or 86%, which includes the absolute success and partial success. Absolute success means 100% when we are saying there is a flood tomorrow, it will come. Partial means when we say there is a flood, but it may delayed, or it may not be, like when say we say moderate flood, but it is a low flood, or when we say low flood, it may be moderate flood. So there's a partial success. If you join together, it will be around 85 to 86%, which is really very, very good. Now I'll come to one by one how we are predicting the rainfall. So for rainfall prediction, we are using the WRF model. This is the core weather research forecast model. We are using 3D where basically module of WRF model. We are using the AWS data, radio sonde data, buoy data, SIP data for wind speed, wind direction, relative humidity, temperature, and pressure. We are using the INSAT 3DR data for wind speed and wind direction. Start with the running the WRM model, generation of the initial and boundary conditions, then inputting to this, and then getting data from this, inputting to this, and finally we get the WRF output. And look, we have to visualize. Then we see where is red color is showing, where is this rainfall, heavy rainfall will be there. Now, what we have done, this directly will go to our hydrological model. We again automated the system. So it will go to the hydrological model, and automatically hydrological model start running. I'll come to that little later. So this is how we do. Now I'm showing you time by time how we are doing. And this is operational in this part of the country. Collection of atmospheric boundary layer information 9 o'clock in the morning. Our assimilation of different local and regional weather parameter 10 a.m. We run the model WRF. We have a high performing computing system here, HPC here. WRF model 10:30 a.m. Then we forecast our rainfall at 11:30 a.m. and immediately the moment it will be forecasted, it will go to our NER DRR website, Northeast Region Disaster Risk Reduction website, and anybody can see that every day 11:30 a.m. what is the rainfall forecast for next 24 hours. For model, of course, for hydrological model, we are using up to 48 hours or 30, maximum up to 48 hours. But in this website, we are putting up to 24 hours because that is most accurate. Then this rainfall will be the input to the distributed. We are using HMS model. Then we are generating the flow hydrograph. Then also, not only that, the moment hydrograph are generated, that time we are also seeing the synoptic weather chart. Then together we are analyzing, and finally by 1:30 we are giving the flood alert. Of course, we are also monitoring limited hydromet informations we have from different organizations like CWC. Our own systems are also there. So you see, there's a classical example of integration of the remote satellite data, integration of the remote sensing data, integration of that field data, and integration of different models, and finally generating the alert. Now we have generated this thing, and we are working since 2012. And success rate, as I already told you, 60% plus 28%, so 88%. Here 70+% plus 20 different years, 22. It's a 90. I told you 85 to 86% for last 10 years I have analyzed. In fact, we started giving after this. There was a request from other states also. We have given for this. But then this is the very important thing. Time is very important in any disaster. Hydrometeorological disaster is also same. So how we start? For dam operators, we should give early warning by 24 hours. For deputy commissioner means relief and rescue officers, 12 hours before. Evacuation plan starts 6 hours before. Then flood will be there. Once flood will be there, then inundation report we have to prepare. So report will be prepared T plus some time, because the moment flood come, we have to prepare. So 6 hours report will be prepared. It will be given to the revenue circle, taluk, and district. Then 12 hours district to state. Then for 24 hours sent district to center, so that they will get information and they will give the money to the people. They will send the relief and rescue, of course, immediately after T0. Then, of course, detailed damage assessment, you can take time, no problem. What is important is these two. First is the early warning, second is the inundation report. In fact, we are running the models for other state also. I've shown example of this. Tripura 5 models, Manipur 2 area, Arunachal Pradesh 7 models, Nagaland 3 models, Meghalaya 8 models, Mizoram 2 models, Sikkim 1 model. Now, this is the 2024 scenario, how many alerts we have given based on this analysis which I have shown you. Assam, we have given 50 alerts. You can see this is Assam, and you can see the areas. In fact, Assam, you must be hearing the news in the TV also nowadays. Now it is reduced, of course. You see this, almost all districts are affected by flood. You can see, and these alerts were given by us 24 hours before and 48 hours before. 50 alerts we have given for Assam. Arunachal Pradesh, we have given 10 alerts. Meghalaya, 10 alerts. Then Tripura, 10 alerts. Mizoram, 1 alert. So these are the alerts which we have given to this area. This is 24/7 our job. I have given you the timeline. When we start at 9 o'clock, timeline will be there. When we start at 12 o'clock, timeline will be there. So our scientists and researchers, 24/7, these 4 months they work. But then you can do the inundation analysis. Many people ask us that I wanted to know at what time my house will be inundated. So for that, such type of scenario you can generate using scenario generation, hypothetical cases. For example, here we have taken 2000 cubic discharge for 12 hours. How much area will be affected? Which area will be affected? That can be analyzed. See, these plain areas are saved because of the embankment. I can tell you in Assam state, more than 4,000 kilometers of length embankments are there, which are saving hundreds of people, thousands of people in this state. But then sometimes it happens, there is a breach in the embankment. So what we are doing, we are first, before flood only, we are generating a report, we are analyzing what are the weak point of the embankment, where is the possibility of breach, how last year river has migrated, whether it is hitting the embankment. This we do using the remote sensing data. Then we are also flying our drones. Finally, we generate the report like that. So then you see the breach. This is a breach point, and then we analyze how much area is inundated. So this analysis also can be done for flood hazard. Now, so how we give the information to the people? One is through email. Second is through web-based. We have a SMS system. Automatically SMS will go to the concerned people. Third one is the web portal. So when you go to our web portal, nerdr.gov.in, you will find alert. Color you see here, if it is low alert, for example, this district is a low alert, you will see low. If it is low to moderate, you can see these districts are affected. So like that. And flood watch, this is another thing we give. Like now there is no flood, but there is a possibility we will have next 48 hours heavy rain. So there is a possibility that they may touch to the danger line. So that this is the area. Like that, we generate the flood alert through our web portal also. So 3 ways: sending the mail, SMS, and the web portal. Now we have already done this, of course, through the common alert protocol. We are integrating the entire portal of this. Now, as I told you that rainfall also information we are giving. So the root, so you know that hydrometeorology disasters, the root cause is the rainfall, extreme event of the rain. So we are running high resolution model. So high resolution model run for rainfall forecast for NER, for flood early warning system. It is operational. We are working. Already I have explained. It not only provide what you call this rainfall prediction, but any we are also giving the nowcasting. So like for example, in next 1 hour you will have highly with a thunderstorm or lightning. That also we are giving, and we are taking help of IITM Pune and NRSC. And this lightning detectors NRSC has put many, ITM has put many, in this entire area, and we are having Doppler weather radar also. So all these data is combined, and we are running the model, and we are giving the nowcasting for lightning also. And our target now, we are giving 9 kilometer by 9 kilometer, but basically our target is the village level prediction for lightning. In lead time should be 3 hours or 2 hours or 1 hour. That we are trying. It is on experimental basis we are working, and these services are available on our website. So if you go to our website, the website name is nerdr.gov.in. And if you go, this is the single window delivery system where all disasters are mapped here. You can click on anything, you will get. And alerts will also be generated like that. Color shows alert, how severe is the alert. Okay, for example, this is the alert which was given on what do you call 20 June 2024 at 9:40 p.m. You see the 20, as I told you, 24/7 scientists are working. This is the Golpara, is the district name, and then we are giving the revenue Taluk headquarter. So this is the Taluk headquarter. Okay, so you see this type of alerts are coming automatically to our website. If you are interested in only hydrological flood hazard, you can go here. If you are interested in meteorological like rainfall, thunderstorm, lightning, you can go here. If you are looking into geological hazard, you can go here. If you are looking for forest fire hazard, you can go here. Like that, you can access our information through that web portal. Like that, you can click on this and you will get the information. So what information you will get? So let us see that information. You will get this information like this. You can get a rainfall map for 24 hours. Red color shows heavy rainfall in this area. Other color shows less, like yellow, moderate, blue, low, you can say. Then hourly accumulated rainfall also we are giving in this website. And of course, this we are fetching through the Inside 3D so that you can see that, compare, and our model and website. This is what we are doing in this. You will get this information. This is very, very important for hydrometeorological disasters. Thunderstorm nowcasting, again, I'm not going to explain about it. Enough, I have explained all these things. Like, we are using the model, then various parameters from the remote sensing data, and we give the, in fact, 3 maps daily with 3-hour lead time we are giving for thunderstorm nowcasting. In this region, thunderstorms are coming from March 15 to June 15. In fact, it starts from, these are basically 1st April to 31st May is the major event, but we have taken grace period of 15 days. So March 15 to June 15 period we give, and this information we are giving to State Disaster Management Authority and the district collectors. And in fact, our probability of detection is, as for now, it is 0.89. So we have a Doppler weather radar. So we generate the scenario through Doppler weather radar also, and we give the information to the concerned departments. Doppler weather radar also gives us the hailstorm conditions. So that also we are doing. So in fact, in my complete talk, I have talked about that what is a geospatial technology? What is that? What kind of information you get from the remote sensing data, GIS data, then field data, how you can use the internet for dissemination, then what kind of mapping you can do, early warning you can do, all these things, and a different like cyclone hazard, thunderstorm, lightning, nowcasting, hailstorm. So that's how you can use the geospatial technology for hydrometeorological disasters. Thank you very much. So anybody can.
Thank you so much, sir, for a very comprehensive talk on the geospatial technology for hydrometeorological disaster. Sir, I know how much you have contributed in this field for last I think around 28 years. So, sir, let me see how many questions are there on. I think there is no questions. So, participants, you are free to ask questions. If you have any queries, please post your queries or questions on the dedicated chat box Q&A.
Shall I stop sharing? My screen is stopped now.
Sir, you can stop it. Nick, is there any question on the today's talk?
No question in the Q&A. No.
Okay. Shall we wait for another 5 minutes?
Yes, maybe someone is a bit shy. Let's wait for other 5 minutes.
Yeah, I can't
Yeah.
see any. Yes, sir. There is one question,
Yeah.
Dr. Aggarwal. Yeah, sir. There is one question has been asked by Mridul Seth. During flood event, can we identify or observe it through satellite at real time?
Yeah. Fine. So now, see, when you are talking about the real time, it means immediately flood happens and you want. Nowadays, earlier, there were a limited satellite and only government agencies were giving the data. But nowadays, there are many private players. They provide the data. In fact, there are various companies all across the globe. And I came across and I talked to them many a times in many conferences. Recently, there was a, Space Congress and other conferences also. I'm meeting many. They can provide the data every 3 hours. And if you have every 3 hour data, almost real time, you get this information.
Sir, in the
One
meantime,
more thing I want to tell, for that, what you need basically to get the data every 3 hour, what you need. One satellite will not work. You should have a constellation of the satellite. You should have, there is one company, they are launching 32 satellite in microwave region. You will get everything. There is one company, I don't want to name because I don't want to what you call highlight their name. One company, they are having 400 plus satellites and they are going to launch 200 more. So 600 satellite they are having and they will give the data every 1 hour. That's what they promised to us. So this is how you get the real time information about the flood inundation.
sir, I will also ask one question. In the meantime, the participants, if they ask. So, sir, you have said that the international charter. So, how it get activated? What is their role in this disaster
Yeah.
management?
No, I think this is a very relevant question, and our participants should know this thing. You know that International Charter for Major Disasters, it was established, and when it is established, the idea was during the disaster, there is no difference between one nation to another nation. Anywhere disaster comes, all the space-faring nations should provide the data to that particular area. For example, there is a, let us say, disaster, hydrometeorological disaster in, let us say, in Indonesia. Now, they suppose their satellite is not there that time. So, India, if ISRO satellite is passing, we can provide. If NASA satellite is passing, they can provide. If ESA satellite is there, they can provide. If Japanese satellite is there, they can provide. But only thing is, you should be a government agency and you should be authorized person and you can activate that charter. The moment you will activate, whichever is the first satellite data is there, it will be given to you. This is how it works.
Sir, one more question has been asked. Sir, all the analysis predict the affected area based on the after the flood condition. Sir, can we able to predict the flood affect area before the flood condition happen using the satellite?
No. See, that's why I have shown one slide on the simulation. So, and very nicely, I have shown that hypothetical simulation. So, what happens generally, we are using the satellite data for getting lot of information, like that land use land cover, slope, topography, digital elevation model flow direction, all these things be here. So we simulate the data, like 100 millimeter of rainfall will be there. Then with this intensity, and we already established the model of that area, then we can go for 2D simulation. But of course, we should have a very high resolution digital elevation model. Many area we are having lidar based digital elevation model that only will help in plain area. So if you have such type of information, you generate the scenario and you can tell that if this much amount of rainfall is there, this much area will be affected. So that's how you can use. But before flood, even satellite cannot capture, but satellite provide the data which can generate the scenarios for different rainfall events in your area.
Thank you so much, sir. I think there is no more question. No, it is there, sir. Some questions are there. Sir, two questions will take, with your permission.
Yeah.
What is the accuracy of flooding prediction using GIS, especially keeping in the mind that the climate trends are changing significantly, as we observed recently that it rained heavily in Delhi after 80 plus years, which led to sudden flooding in the city?
Okay. Fine. So what you understand from this, your question is having answer. That 80 years flood. Sorry. So so extreme events are changing. So what is most important now? To predict accurately these extreme events. This is most important. Number one. Number two, urban area flooding. Urban area flooding nowadays everywhere it is happening. There are two regions of it. One is of course extreme events are happening more nowadays because of the climate change. Second is that, see, urban area basically where you are establishing your house and building your house or roads and all over a natural drainage system, natural land. So you are basically totally stopping those natural land. Third one is you have your urban area which is designed, the sewer line is designed 30 years before. That time, that much population, those many buildings were not there. So whenever rainfall comes, it is going away through the sewer line. Now, population has increased, impervious layer has increased. So combination effect of extreme events and more impervious layer and less capacity of the sewer line, it create a havoc in the all the urban area, not only in our country, across the globe. This is the problem. But prediction, extreme event prediction, now I can assure you very accurately we are giving now. Of course, IMD has given very accurate prediction of the heavy rainfall, but then quantification of that rainfall and how it is going to affect the urban area. For that, we should have a information of the not only the sewer line, integrated approach of hydrological modeling is required, where you should have a even micro relief information of the city, which is very, very important, which you don't have. So this is another area. Okay.
Yes, sir. So last one, there are two questions have come. This question has been asked by Abhishek Kumar Thakur. How can we validate our flood inundation mapping?
Validate means flood inundation when you are getting from micro data, optical data. It is perfect. There is no question of that. But if you are talking about the flood predictions, for that, what we are doing, we are simply from our flood prediction, we are getting the affected area. Then on that day when flood comes, we take a micro data and then we are what you call matching the area. So based on that only we tell our model is 80% accurate or 100% accurate.
Right. Sir, there is a last question. Do we have any data repository for the drainage systems?
For Northeast, I can say yes, we have. We have a river atlas for entire Assam, where 22 layers are there, which includes the drainage network, which includes the road network, which include that you name it, culvert, aqueduct, every canal network, everything is there. For India, I'm sure NRSC may be having. If you don't have nowadays, getting a drainage network through from DM is very easy. So if you are a hydrologist, you can understand that. Yeah. Any other question?
Sir, I think this question is more relevant to you now. It has been asked on chat. Uh, Sir, can we able to download the data for NER, Northeastern Region Disaster Risk
Yeah, yeah,
NERDRR website?
yeah. Fine. So, see, this is one website. In fact, we are having a complete, package of the websites. That is our main portal. That is the NESDR, Northeastern Spatial Data Repository. Through that, you will go to the NERDR wherever you want to. There are 25 portals within that also. You go reach to that area. What you want? You want Danish network. So what you have to do? First, you go to the NESDR website, register yourself. You have to register only one time. Then you ask which data you want. You can visualize it from our website, but you can ask this data I want. You give the lat long or polygon, save file, whatever you want. Then the request will, you fill a form. Then data privacy form will be there. It will come to us. We will see that you are a genuine person. If it is so, we will send you the data. We will send you the link. In fact, Dr. Dibyajyoti, who is the head of Geoinformatics region, he has given the website in the chat box also, www.nesdr.gov.in. Or you can Google it, NESDR. You can reach to that website also. Now you will ask me how much time it will take. In fact, if you are government organization, the moment you will register, the moment you will give, generally we take 1 day. This is our time actually, turnout time. So people are very happy here. More than 100 organizations of Northeast region are downloading our data from this portal, NESDR portal.
Sir, I think you have answered all the questions, the queries raised by the participants, and it was really a wonderful talk by you, sir. And personally, I thank you. You are my father figure, and it was really a nice meeting you after a long time as well, even though it is online. So thank you so much, sir, for today's talk, and we look forward for future cooperation also for this kind of activities.
Okay. Thank you.
Thank you.
Thank you very much, Dr. Vaibhav. And thanks, Dr. Praveen, for inviting me. And in fact, I can see ISPRS Student Consortium. Uh, Gentleman is there. Thanks for joining, and I thanks all the participants. Thank you.
Thank you, sir.
Okay.
Thank you,
I'm
Nick.
leaving now.